Thank you, and first of all, thank you for the invitation. I'm very honored to be here and to meet you and your students. And I hope that I will be able to share some very useful information today with you. I'm a teacher at the Budapest Metropolitan University, and I teach at the animation department. I'm teaching animation design and animating, so especially this frame-by-frame animation technique about I will talk you today in this webinar. In the same time, beside being a teacher, I'm a practicing animation artist as well. And at the moment, I'm working in a project, in a feature animation movie project. Feature movie means that it's not a short animation, it's a long animation movie, so it's more than an hour. And I will share some experience from that project as well with you, and I will show a very short scene from that movie as well, which is now in production. Okay, so let's start. Animation is a motion picture. The motion picture was invented a little bit more than 100 years ago, so it's a quite new art genre. And the motion picture actually is a sequence of still images. When we are looking in the reality to a movement, to our friend playing the basketball or whatever, we can see a smooth, real movement. But the motion picture technically is not a smooth movement. The motion picture is a sequence of still images, which is recorded frame by frame and is put together and is played in front of our eyes consecutively. And in this way, we have the illusion that we can see a smooth motion picture. As I told before, the motion picture is an illusion based on the persistence of the human eyes. What does it mean? This means that the human eyes has that property that after an object or an image disappears from the front of our eyes, we still have for a very short time an image of it in our eyes and in our brain. In this way, an image sequence which is played consecutively in front of our eyes, our brain and our eyes creates the illusion that we can see a continuous motion picture. Yeah? What I'm showing here to you, these are some photography sequences, which are showing exactly the way how a camera, how our phones already today, with the development of the technology, can record a motion picture. Actually, our phones is recording an image sequence frame by frame. And when it is played back, our brain makes from that, for us, the illusion of a continuous and smooth motion picture. Just a very short idea from the history of the motion picture. Creating the image sequences, it's not a new thing. You can see that Edward Muybridge, who was a British inventor, he made an experiment which became later very famous. As you can see, at the end of the 19th century, in 1878, so it's 150 years ago. And this experiment was related to a galloping horse. Actually, what is interesting is that he didn't make this experiment in order to invent the motion picture. At that time, the motion picture didn't exist yet. Photography existed, but no motion picture yet, because there were no cameras which were able to record these image sequences. But Edward Muybridge was asked by a businessman to make this experiment. And the aim of this experiment was very interesting because it was that they wanted to find out if there is a moment for the horse when it's running, when it's not touching with any of his legs of the ground. Yeah. So the question was, is it possible that the horse has a position when none of his legs touch the ground? Yeah. And we can see on these above images that yes, it is. So why is this interesting? Because when we are looking to a running horse with in the reality, yeah, so when we see a horse for real, the horse is running so fast that we can't figure out how its legs are moving. And this image sequence, this photography sequence experiment, that was very important because this catched the motion. Yeah? So that was just one step from the discovering and inventing the motion picture. Another interesting technical addition is that this image sequences, you can see that we have here 16 images. These were created with 16 separate photo cameras. So it was no camera which was able to create a sequence. These were 16 separately photo cameras. And I will show to you now what happens when these pictures are put together for a motion picture. Yeah. So here you can see a very, very early movie about this running horse, but of course this was not created to be a movie. Yeah, it was just an interesting experiment, a study of the motion of the horse. Okay. The question is, we have seen that there were 16 pictures in the case of Edward Muybridge experiment. But the question is today, how many pictures, how many images are necessary to have in a second in order to create a smooth movement? So there are different motion picture standards. Here in Europe, we use 24 or 25 frames in a second. Actually, the 24 is more a cinema standard. That's generally all over the world is the same. The 25 is a standard for television broadcasting, but for example, in the USA, this standard is 30 FPS. The FPS, this is frame per second, yeah, the abbreviation of the frame per second. But of course, with the development of the technology, today the digital cameras can shoot at a very high frame rate, at a very high frame per second rate, 60 frames per second or above. Yeah, so the digital camera today are very, very developed, and they can record very amazing details from movements and to create motion pictures from them. Okay, so this was a very short introduction related to the motion picture, and that was important because animation is a motion picture as well. We have seen that the live motion picture, the live recording, they contain photographies, yeah, live pictures. Animation, instead of live pictures, the frame by frame drawing animation contains drawings, yeah. So all these frames that we were talking about previously, these frames should be drawn. We talked about the motion picture standards, and 24, 25 frames per second are necessary. But in order to obtain a smooth movement, an average of 12 drawings per second are enough in order to create a smooth movement. These are good news, yeah, because we have to draw less. So not 24 drawings for a second, just 12 drawings for a second. And this means that we have to draw a new drawing to every second frame, yeah. But still, if you can imagine that you are working on a character, you are drawing a character, you are drawing it 12 times, and you still have 1 second, yeah? So you can imagine that creating animation is a huge work. It needs a lot of time, a lot of energy, but the good part of it that the result can be very, very amazing and impressive. So just imagine that you create your own character, you draw a character which didn't exist until now, and when you make it moving, it comes to life. Yeah, so this is like you are creating. Of course, it's not a really live creature, but it's close to it. Okay, so we discussed before that the motion picture is around 120 years old. And the frame-by-frame animation, the first frame-by-frame animation were made at the beginning of the 20th century. So more than 100 years as well. Of course, at that time, there were no computers, no digital technology, no softwares, and all these technical things, the very first animators, they served in an analog way. And a very important invention, what they used, it was the light table and the PEG system. I will explain immediately what the PEG system is. The light table, this light table in the picture, of course, this is not a 100 years old light table. This is a modern light table, but the principle is the same. So there is a transparent sheet. It was earlier, it was a sheet of glass. In this case, in this modern case, this is already a plastic. And below it, there was a source of light. Yeah. In this case, in this modern case, this was already lighted with LEDs. And why is this important? This is important because in order to draw the frames, it's very important to see the previous one and the next one. Yeah, we will see how we create. We will see immediately how we create the frames. So it's very important to see the paper below on that paper on which we are drawing, are working at the moment. The PEG system is this paper and this PEG bar here. I have a separate photo about the PEG bars. These are different standards, yeah. But the PEG bar is a metallic bar, but now it can be from plastic as well. You can see its size, yeah. It's not so big. It's around 20 centimeters. And these are the PEGs on it, yeah. These are the different standards which are used in different studios. In our school, we use this PEG from here, this very simple one. And we use the punched paper, yeah. This is punched with a very simple office puncher, yeah. And that's why we're using this system, because it's easily available for the students and for everyone. And why is necessary this? Because you can see that this paper is put on this PEG bar, and in this way we can keep the drawings, the paper, exactly in the same place. This is important because when we are drawing the next frame, we must see where the previous one was, yeah? Because if we cannot see the drawing before, probably our drawing will be not correct, will be not right, yeah? So in this picture, you can see a drawing on a light table. These two drawings are on the papers below, and this is the actual drawing on which the animator is working. And here in the corner, you can see the peg bar, yeah, and with the punched paper. So this is how the principle of the drawing animation works. And this is a technology which is more than 100 years old. And you will see that even today, we are working already on digital tools in softwares with digital drawing tablets, but the basic idea is perfectly the same. Yeah, so that didn't change. Okay, this is another picture about how this frame by frame animation is working. So we can see on the light table the previous drawings, and we can look on the papers below, because these papers are kept fixed by those peg bars. Yeah. Okay, so that was the analog. Of course, after the pictures are created, today they are scanned, they are already transferred in a digital environment, and they are continued to work with in a digital environment. Earlier, the shooting was made on film, but we will not enter in those details now. Okay, so let's shift to the digital era. Yeah, I'm sure that many of you know these tools, these objects. These are digital tools for drawings. Of course, these can be used for many purposes, not just for animation, but for painting, drawing, graphic design, 3D animation, or 3D modeling. They can be used in very varied ways. The first one, the pen tablet. This is the simpler solution, and this is a little bit harder to use because this should be connected to a computer, and this works as a mouse actually. So we draw on this, because this is a plastic sheet actually of a size of a book, or probably a little bit bigger. And as we draw on this plastic surface, we can see the image on the monitor. Yeah, so it's difficult a little bit because we draw on the plastic, but we have to look at the monitor, so we can't really see our hand as we are drawing. That's why this is a little bit more difficult to work with, but with some experience, it can be very, very useful. Sorry. The other tool is the pen display. And you can see that this is similar to this, but the big difference is that it has here a display, yeah, a monitor. And we are drawing with the pen directly on this monitor. And of course, this should be connected to the computer as well, but we can see very easy what we are drawing. Yeah, so it's very similar to drawing on a paper. Yeah, so this is more comfortable to draw with this. Of course, this tool is a little bit more expensive because it's more professional. By the way, these two tools are made by a Chinese brand, which is called Huion. And we use at our school pen displays from this brand, and they work just perfect. Yeah, so these are very, very good tools. Okay, I mentioned before that we have to connect these tools to a computer, and of course, we need some softwares in order to create the animation. I put here some softwares which are suitable for creating frame-by-frame animation. The first one, the TV Paint. This is a quite widespread software. This is made by a French company, and we use this at our school and here in Hungary. This is used by many studios, but of course not just here in Hungary. And later in this presentation, I will show you the interface, and I will show you very briefly how it looks when you create a project in it or animation in it. The next one, the OpenToonz. This is very important because it's completely free. Yeah, the others are shareware softwares, but the OpenToonz is completely free. This is created and developed by the famous Japanese studio, the Ghibli studio, and it can be downloaded from their page. It's completely free, and what is important that this is a professional software. So many free applications, are very basic, or they are very limited in possibilities, but this one is created by professionals and it works very well. It's not so widely used yet because it's quite new, made free, but I'm sure that it will be used. And two further softwares are the Toon Boom, which is very similar to the TV Paint, and Adobe Animate, the part of the Adobe Creative Pack, yeah, and which was earlier it was the Adobe Flash, and now it's Adobe Animate, and it's transformed a little bit more in order to be suitable for frame-by-frame animation, but originally it was not created for that. But it can be used as well, the actual versions. Okay,